Alright, welcome back. This is the second video in the Exponent series. In this one I'm going to show you the actual rules of simplifying problems using the rules of exponents. We're going to start off with just multiplication and division and go from there. So the first thing is for multiplication, if you are multiplying two things with the same base, you add the exponent. So let me show you why that's the case. So say you have something like 3 to the 4th power times 3 to the 2nd power equals, what does that equal? Well, let's write out in longhand. In the previous video we just learned what 3 to the 4th power means. 3 to the 4th power means 3 times 3 times 3 times 3, right? So the 3 to the 4th means 3 times 3 times 3 times 3. Then we have another multiplication symbol. And now what does 3 squared mean? 3 squared means 3 times 3. So the grand total is 3 times 3 times 3 times 3 times 3 times 3, which equals 3 to the 6th power. And of course you can see if you add that exponent to that exponent, you get that exponent. But it should make sense to you. I mean, this rule is not some crazy made-up rule by smart people. It's a common sense rule based on the definition of what these exponents mean. This is your 3 to the 4th. This is your 3 squared. And that exponent, remember, just represents the number of times you're multiplying something together. So if you multiply it 4 times and then you multiply it 2 times, you've multiplied it for a total of 6 times. Let me give you one more example. What if we had 5 to the 11th power times 5 to the 3rd power? Again, 5 to the 11th power means 5 times 5 times 5 times 5, 11, and you just do that 11 times. I'm not going to write it out, but that's what it means. And then when you multiply by 5 to the 3rd, you're multiplying times 5 times 5 times 5 3 more times. So the grand total is 5 to the 14th power. Okay. How about division? Division is very similar. The concept behind the rule is going to be the same. So let's start with a different example. Let's start with 7 to the 5th power divided by 7 to the 3rd power. Okay. 7 to the 5th power literally means 7 times 7 times 7 times 7 times 7. Okay, divided by, what does 7 to the 3rd power mean? It means 7 times 7 times 7. Okay, there's 3 7s here, there's 5 7s here. Now, you know that 7 divided by 7 reduces. 7 divided by 7 reduces. 7 by 7 reduces to 1. So what we're left with is just 7 to the 2nd power. Okay? So you can see right away that if you have 5 7s in the top and 3 7s in the bottom, 3 of them will cancel out. There will be 2 left over. So the shortcut for this is this exponent minus this exponent equals this exponent. So because every time you divide, you're reducing the number of 7s by 1, you subtract the amount of 7s that you have. So what if we had 6 to the 20th power divided to the 14th power? That's going to equal 6 to the, you can even show your work here, the exponents will subtract, so we could go 6 to the 20 minus 14 equals 6 to the 6th. Now let me show you some notation that's actually important that you don't do. So some notation that you should avoid. I'll put this in like a different color. Let's put it in green. So you want to avoid writing 6 to the 20th minus 6 to the 14th equals 6 to the 6th. So even though in your head you know that you're subtracting the exponents, you know that you're doing 20 minus 14 equals 6, you can't write it like this because this is a different problem. What you started with here right, was 6 to the 20th divided by 6 to the 14th. And what you've written over here is 6 to the 20th minus 6 to the 14th. So this one here, let me do that in a different color here. This one here is true, while this one here is actually false. 6 to the 20th minus 6 to the 14th is not equal to 6 to the 6th. So just make sure that you're aware of this notation sort of problem. Okay, let's move on and do a couple more rules of exponents in addition to multiply and divide, and we'll see what we can find. Next up, we're going to do 3 more rules of exponents. We're going to do power of a power first. So what happens when you have an exponent, which is some number raised to a power, and then you raise that whole expression to a power? So we'll find out right now. So say you have something like 5 squared, that's your expression, and that whole thing is raised to, let's say, the 4th power. Okay? Well, you're still going to follow your normal rule of exponents. What does 5 squared mean? It means 5 times 5. What does something, this whole base here, to the 4th power mean? It means this whole thing 4 times over. So let's start on the outside and work our way. Actually, let's start on the inside because we're following PEMDAS. Let's start on the inside and write this here as 5 times 5 to the 4th power. Okay. So what we want to do is we want to take whatever's on the inside and write it out 4 times. So that means we have 5 times 5. Let me just put in my parentheses here. So notice I have 4 sets of parentheses, and inside each set of parentheses, I'm going to put whatever I had right here, which is 5 times 5, 5 times 5, and 5 times 5. And I hope that now you can see what we have is 5 times 5, and we have a grand total of 8 times. So our result is 5 to the 8th power. Okay, and what shortcut? I'm sure you guys can all see it. In fact, if you just multiply the 2 exponents together, then you will get this new exponent. And it's because a power of a power is telling you how many times to multiply. So you multiply or times the 2 numbers together, and that will give you the grand total number of that base. Okay? So a power of a power, you multiply the 2 things together when you have a numerical base and a numerical exponent. Okay, 0 exponent. What if you have something to the 0 power? Okay, this one, it's a little more tricky to explain, but I'll do my best. So you know that 3 to the 1st power equals 3. And you know that 3 to the 2nd power equals 3 times 3. So what about 3 to the 0? Sorry, I'm running out of space here, but just as a thought process, what does 3 to the 0 equal? Well, here you have 2 3s, here you have 1 3, so here you're not gonna have any 3s at all. So I think it's obvious that the answer is either it's gonna be 0 or it's gonna be 1. If you don't have any 3s, what do you have left? Now you can multiply this by 1, and it's the same thing. You can multiply this by 1. So I hope that, I mean, this is not the mathematical definition, so to speak, but it's the way that I like to remember it. 3 squared is 3 times 3 times 1. 3 to the 1st power is 3 times 1. 3 to the 0 power, well, all the 3's are gone. All you have left is the 1. So 3 to the 0 power, there are no 3's. That's what it's saying. There's 0 3's, but you still have this 1. So in fact, the general rule is that anything to the 0 power equals 1. So you don't have whatever that is. It could be a 3, a 5, a 7, a smiley face, who cares? You don't have any of it, so all you have is 1. Since exponents are part of multiplication, when you reduce multiplication, it reduces to a 1, not to a 0. If it were adding and subtracting, it would reduce to 0. Multiplication and division reduce to 1. Okay, so anything to the 0 power is 1. And our very last type of exponent rule is this rule of negative exponents. So what happens, let's look at a division problem and help introduce it. What happens if you have 2 to the third divided by 2 to the fifth power. Okay? From our previous rule, dividing exponents, we know that we should subtract these exponents. So we should write 2 to the power of 3 minus 5, which is 2 to the power negative 2. What the heck does this negative 2 exponent mean? Okay, first of all, let me say this is the right answer. 2 to the negative 2 is the correct answer. Let's look at this another way. Let's look at this as 2 times 2 times 2 divided by 2 times 2 times 2 times 2 times 2. Since we already said that you could always write these out in longhand, now these will cancel, cancel, cancel. So this equals 1 over 2 times 2. We could write that as 2 squared. Okay, so this is also the right answer. So if these are both the right answer, then they must be equivalent to each other. So this is kind of a discovery. We've discovered that a negative exponent means the same thing as putting that entire base and exponent in the denominator. Okay, so you flip it from the numerator into the denominator. So let me give you just 2 more examples. So that means, like, say we had 5 to the negative third power. Hold on, let me fix this negative 3. Uh-oh, it's going away. Okay, here we go. 5 to the negative third power. That's going to equal 1 over 5 to the positive third power. So that negative in the exponent, think of it as it moves it from the numerator to the denominator. Okay? Okay, let's get even one step more complex. What if you had 1 over 6 to the negative 2? Okay? Well, now this is in the denominator, and it's a negative exponent. Well, the negative exponent says move it to the denominator, right? What if you're already in the denominator? If you move it to the denominator of the denominator, that actually moves it to the numerator. Think about when you divide fractions. That's the same as multiplying by the reciprocal, right? Dividing fractions is multiplying by the reciprocal. Well, a negative exponent in the denominator is like multiplying in the numerator. So dividing in the denominator is the same as multiplying in the numerator. So if you have a negative exponent in the denominator, it goes up the whole thing, not just, so positive 2. The whole thing, the base and the exponent, go up to the numerator. If you had a negative in the numerator, then the whole thing, base and exponent, go into the denominator. So here's your 5 rules of exponents. Hopefully this was mostly review, but if it is new stuff, feel free to ask me in class for additional assistance, and I'm glad to help you. All right, and good luck with your homework.